In this video, we'll be looking at processing narrowband data. I'm not presenting this as the only way to process narrowband, just what I think is the best way. I'm also using PixInsight for its. The basic workflow is to crop, stretch, remove stars, and combine to get the color data. For stars, we've got separate RGB, where we combine, calibrate, and extract using StarXTerminator. And for luminance, we'll likely just take the HA, but we'll process that with maybe HDR Multi-Scale LocalHistrogramTransformation, and maybe a DarkStructureEnhance. To start, I've already integrated and removed light pollution in AstroPixel processor. I integrated my HA, red, green, and blue separately to my O3, which I took with different telescopes. So we'll also look at how to use star alignment to align different channels together. So if we load up all 5 channels, this is our O3, and we've got our HA, red, green, and blue. Tidy things up by renaming. This is a red, HA, green, blue, and this is our O3. We can Command A or Control A on Windows, have a look. That's what our O3 looks like. Our blue, our green, HA, and our red data. So we need to align our O3 to, we'll align that to our red data. So we go up to Processes and go down to Star Alignment. Our reference image is going to be red. Okay. At blue, we need to align our O3. Click OK. And close that down. To Control A, Command A. And now we can close this one off. First up, we want to do a dynamic crop. So first, we'll create our RGB stars. So we're going to do a channel combination and a photometric color calibration. And then we're going to remove the stars and stretch the stars. Just a light stretch. So channel combination, red, green, circle. A stretch. So first up, we want to apply a photometric color calibration. Photometric color calibration to get the coordinates. This is SH2132. Search, get. Don't forget our focal length. It's 30. And our pixel scale is 3.76. That's good, and we want to check our background levels. Looks like about 0.32. 0.32. We apply that. This is going to take a while, so I'll come back when this is finished. So this is finished. So this has a nice linear fit. So our data was fairly well balanced, but it's always good to run a photometric color calibration. So if we close that, close this, we can re-stretch. Have a look. Yeah, that's nicely balanced, the background. So the star color looks pretty similar, but our background is nicely neutralized. So we want to stretch this slightly first before we remove the stars. I find that works slightly better. So if we go into our histogram transformation, I kind of like the screen transfer stretch that's on it, so I'm just going to copy that. So to copy the stretch that the STF has, we take out our STF screen transfer function here, and we can drag this little triangle to down here. There's a little bit of a quirkiness with PixInsight, but this will apply the STF to the histogram. You can see that it's changed to this stretch here, and then we can apply this to the image, and then turn off the stretch, and we should have the same stretch. So it's the same stretch as what we had for the linear data in screen transfer mode, but now this is the permanent stretch. So now what we want to do is run a StarXTerminator. You can use StarNet v2 if you want, but my preference is StarXTerminator. It seems to work very well, especially for my spiky stars. And as well, StarXTerminator does an on-screen. So I'm going to generate the star image with on-screen ticked. We apply that to our image. This will take a while as well, so I'll fast forward. Okay, so that's complete. We have our stars. So we're going to rename this as stars. And we no longer need this image. So I'm going to put my stars up here. So the next thing we want to do is combine our HOO. So first we're going to stretch lightly our HA and our O3 using Histogram Transformation, just a light stretch. I think it's better to do it this way. And then remove the stars. So we have our O3 registered. We'll call this O3. So we'll take our histogram transformation, and we'll preview and remove the stretch. And again, it's a mid-tone stretch, so grab that middle slider, bring it over, bring the blacks down. So again, we want to get our histogram somewhere in between these two first bars. It's starting to look good. Maybe 1/3 stretch will do it. So something like this, roughly. Okay, I think that's fine for our O3. You can see the O3 data is very faint. I think we'll have to apply a curves transformation to it to line it up with our HA, which is very strong. So if we do a light stretch in our HA now, like that, turn off the stretch. It's the first stretch. Second stretch. I might not apply as big a stretch. Don't want to blow out that central core here, which seems to be quite bright, relatively. So I think that's good enough there. So apply that. And these are stretched enough now that we can remove the stars. So I'm going to run StarXTerminator. We don't need to keep the stars, so we can turn off generate star image and drag that over to the O3. I'll fast forward to the end. Actually, whilst that's processing, we can talk a little bit about my workflow here. So we're going to get color data, so chroma data. So we're going to combine our HA and our O3, and we're going to get some nice color data, a nice color combination. And we're going to use that purely for our color. Then separately, we want a luminance. Most likely, we'll just take the HA. The signal in the HA overlaps with the O3. We can have a look and see. I think just taking the HA will probably work as our luminance. And then we have separate RGB stars. So we want these 3 separate images, and we're going to take these 3 separate images, and we're going to take those into Photoshop, and we're going to apply adjustments to each of those individually. So the adjustments we want to apply to the color is different to the adjustments we want to apply to the luminance. And also within PixInsight, to our luminance, we've also applied some additional processing that we don't need for the color. So we're going to use PixInsight for its strengths, which is a lot of it is the kind of Mathy-based tools within PixInsight. And then Photoshop is great for combining and iterating and tweaking. And for masks, etc., Photoshop, it's far easier to work with masks. And the fact that it's non-destructive as well means that you can iterate quickly and make adjustments and see how they play. So you might up the saturation in the color data, and that will have an effect on the image with luminance applied to it. And equally, if you apply more luminance, means that you might also then have to go and readjust the saturation. And all the while, we're just applying these adjustments on the nebulosity and not on the stars. And at the end, we can take our stars and we can tweak the color of the stars and the brightness of the stars to kind of blend in nicely with everything else. So that's my basic workflow and why I kind of break things out and why I use AstroPixel Processor for integration, because I think as a tool, it's, for me at least, the way I work and collect data, is the best tool for the job. And equally, I think the remove light pollution and APP is the best tool, so I like using it there. Then I bring everything into PixInsight, and I break out the colors. So I break everything out into the data. I break everything out into this chroma or chrominance or just color data, and separately we have our luminance, and then stars are something separate. And then all the little tweaking and masks and color adjustments, Photoshop is best suited for. So that's the O3 with the stars removed. So now if we do the same thing to our HA data. So this will take a while and we'll come back when it's finished. Okay, so that's finished. So now we're going to do some HOO combinations. Really at this stage, we just want to check out the relative strength of each channel. So we use some pixel math to do this. We want to turn off use single expression because we actually want to say what the red, green, and blue channels are. So red is HA, green is O3, and blue is O3. Go to destination. We want to say create a new image. Color space is going to be RGB. So if we apply that, we have a first look at what our HOO is going to look like. So all this HA region is kind of all red, and then we have a very muted O3. So as I mentioned earlier, I think the O3 signal needs to get bumped up just a little. So we're going to close that. We're not going to use this combination. What we're going to go and do is run a curves transformation over our O3 just to bump it up a little bit. So curves transformation. Let's reset, apply. We'll use a preview. So just something like a little S curve. We can have a look. If you click on part of the image, you'll see over on the curves transformation where that point is. So we want roughly this data here. So from here down, we want to maybe add a little bit of contrast. We certainly want to bump up here, and from here down, we want to keep roughly the same color. So we want to apply curves to that nebulosity, but keep the background roughly the same. So I think let's try that. And I think we'll apply the same again, and maybe even a third time. Yeah, let's try that. Okay, let's try this. We'll run our pixel math again just to have a see. And this is looking a little bit better. The O3 is starting to shine through a little bit and also give a little bit of color contrast here. I think that's reasonable. I think we can go with that. So because we've had to stretch it so much, I think we've also stretched out the noise. So I think I'm going to apply a noise exterminator just to the O3. The HA data doesn't need it. So if we run noise exterminator, again, you can use your denoise of choice. I'm going to create a little preview just to have a look. And I would maybe about 33%. Let's have a look. And see, we don't want to make it too plastic looking. And keep a little bit of the grain, but take out a lot of the noise. I think that's perfect. That's perfect, okay. So we apply that to the whole image now, not just the preview. And we're going to close this down because this has the O3 data without the denoise, and we'll run our pixel math again to regenerate that HOO. So we're going to keep this. This is a straight HOO, so we'll call that HOO. I have some processes that I have that I used quite a bit saved out, so I'm going to load those up. Process icons, you can do the same. So you can create a process, you can save all your process icons. This saves you having to remember formulae. So I close my pixel map here. We can close the screen transfer and noise exterminator and StarXTerminator. We can move those. We can have a look. So I have a blended green. So if I open that up, so red is still HA, blue is still O3, but green is now a blend of O3 and HA. So I can run that as well. We'll have a look at that one. It's kind of interesting as well. We can have a look at both of those. That's the HOO, and that's the blended. So we'll call this blended HOO. The green is blended. And then my favorite, just typically my favorite is this dynamic. I'll put a link to the website where you can get these formulae from, but I like this one. So red is just straight HA, blue is O3, and then this very funky looking combination in green, but that usually produces a nice additional color. Yeah, so that's looking nice as well. That's my favorite of the three so far. Further with that one, but it's good, I think, to just have a couple of different color calibrations, because depending on the target and the colors, the channels that you have and the varying strengths that you have, something will typically jump out of one of those different combinations. This dynamic HOO is usually my go-to, so I'm gonna stick with this. So I'm going to close down the blended. Oh, I was going to call this our HOO. And that's our color data. I think that's now ready to bring into Photoshop, and we can do whatever final tweaks we want to it there. So now for our luminance, close down our O3 for the moment. Okay, so we have our HA data, and we're going to look at turning this into a nice luminosity. So I think first up, we might see what a HDR Multi-Scale Transformation will do. It's quite bright in the central area there. It's not too bright. It's actually quite nice, but I think there's some details there that we can bring out with the HDR Multi-Scale. It's always worth trying, I think. So if we reset this, we want to take the Lightness Mask, and it starts off with a number of layers of 6. So let's create a little preview of this, especially this central area. And if we apply this, yeah, so that's quite nice. Let's brought out some of that. It's muted those bright areas just a little bit. And it's going to reveal some details. That's quite nice. Let's apply that to the whole image. So the lightness mask is, I think, quite important for this HDR. We want to apply the HDR multi-scale more to those brighter areas, and we don't want to apply it to those dark regions. This looks nice if we do the whole image. That's before, that's after. You can see it's just applied it to that central kind of core area, but it's brought out a lot of nice details. So I think next we'll have a look at the local histogram transformation. It's one of my favorite processes as well. And for this we have the luxury of a preview, and that's way too much. Let's reset this. Okay, so this off the bat is way too much, so we can dial the amount down, probably 30% or less. You can create a little preview within this preview as well by clicking that little button down there, the little squares, and dragging the rectangle, and it will zoom in. And this little circle up here is your toggle for on or off. So this is before, this is after. It's way too much. I think if we just want to keep it to those small detail, I might drag the current radius down to 32 or so and have a look. So before, after, we're getting there. I think we'll bring the contrast limit down a little bit, maybe 1.75. We'll have a look at this. Just a little bit less contrast. This is looking not too bad. I think we can bring the amount down. It's maybe 20% of a blend. Again, I like it. It's just bringing that contrast out a little bit in that central region. I think that this is going to work. So then if we apply that to the full image. Okay, so I think we're not doing too bad. Let's delete the preview. And our luminance is looking good. These dark bands, it might be nice to accentuate those a little bit. So let's see what the DarkStructureEnhance is going to do for us. And typically you want to bring this right down. I think maybe even 15%, 20% is typically where I'd run it, and one iteration is fine. The rest are defaults. So again, we just want to create that kind of tension and that contrast, which is what you want in a good luminance. So let's have a look at before and after. Yeah, before, after. Yeah, so it's darkened up those dust lanes just that little bit, which is nice. Yeah, no, that's good to me. Okay, I think that's it for our luminance. I think that's good enough. We can do the rest of our adjustments in Photoshop. So I'm now going to rename this my luminance and bring it up here. So what we want to do now is we want to save out all three of these images as 16-bit TIFFs so we can bring them into Photoshop. So let's do that now. These are our stars. I'll save as. Let's create a new folder under here. Photoshop 2. And save this as stars.tiff and then 16-bit. That's our stars saved. We want to save our HOO. HOO is TIFF 16-bit. And then our luminance. Photoshop 2. Save it as a TIFF. This luminance 16-bit. Okay. So now we can jump into Photoshop. And we can load up all three channels. Enter Photoshop 2, load up all three channels. Okay, so we have our three channels loaded. Here we have our stars, we have our HOO, which is going to be our chrominance data, and we have our luminance data as well. So for our luminance, we want to do a Command A and then a Command C to copy. We go to our HOO and we do a Command B. So just paste the luminance as another layer on top of our background here. So we could call this chrominance, call this luminance. And then we do the same for our stars. We do a Command A, Command copy, go back to the layers. Then we want to set the blending mode for our stars. Let's rename this stars. So the blending mode for stars to be screen. And then for our luminance, we want to set this to be luminosity. So this is the first look at our image. First thing we want to do is for our luminance, so let's turn off stars for the moment. For our luminance data, we want to apply a levels. So we should get our little dropper here and then find some, what should be just a nice neutral background, and maybe those two, maybe here. And we can just have a look at our varying levels. Red seems to be slightly higher than the green and the blue. And we can bring all of our levels down. So if we do an adjustment on our levels, so adjustment levels, if we have our luminance layer selected, click on this adjustment, then click on little luminance icon here, and we can drag this slider over, which will darken our luminosity. And we're just having a look at these values here. We want to bring these down. I typically, the blackest I want is about 24 here. We want to leave a little bit of headroom for curves. So maybe about here looks good, but we can see our red level is definitely higher. So if we do want to pick, let's maybe add a little color dropper to here as well, because we have some hydrogen alpha in the background as well. So we definitely want an area where, here, if anything, our red is a bit less or lower. So for these black, I'm going to just zoom in here for a little bit. Have a look for a black area, or an area that should be black. These dust lanes should be roughly black. Number 6 here, that's pretty close. I think we might just drop the red down a little bit just to see. So here we've selected RGB in our levels. So we can just select the red channel and we can drag that down. And you can watch the values change of all of these here as you're dragging it down. And you can see what's happening to the image. So our image is definitely red tinted. So if we just bring that down, maybe 1, I think that's not too bad. This number 6, this area here we picked, that's close enough. We might even try and get that to be black. So we might take our green data and bring that down, just down 1. And we'll say that that's at least our initial levels adjustment. Now what's nice about Photoshop is this is non-destructive. Oh yes, so we also want to apply this adjustment to just our luminance data. So you have to clip it. Right now it's applying that luminance to, or it's applying this levels to both or all the layers below it. So you want to click on this little clip here. And this little arrow means just apply this adjustment to the luminosity. And you can toggle this on or off, and you can see what that's done. So we brought our levels down as a first kind of adjustment, getting our background close to where we want it to be, but we've left ourselves a little bit of headroom. So the next thing to do is a little bit of a curves then, I think, on the luminance. Click on curves, let's drag that above the levels we want to do it after. Click on our curves adjustment here, and this is just like curves transformation in PixInsight, where we might give a little bit of a boost here, but we want to give a little bit of contrast to the image. So again, we want to keep an eye on our little samples here, making sure our background level doesn't go too low. But we want to introduce, as I say, just a little bit of contrast, so a small little S curve. I think that's looking good there. And you can flick on and off your stars and see, and the stars are completely overwhelming in this image. So, but we'll adjust those later. And again, you can also see just what your luminance is doing to your chrominance data. So there's our chrominance data, and we add our luminance, and all that nice detail is coming out. So as well, typically, when you bump up the luminance like that, you want to add a little bit of saturation to your color data. It removes saturation when you apply a bit of a contrast or you bump up your luminance in any way. So let's go down to our chrominance layer, and an adjustment here we'll apply is the vibrance and saturation. So there's no need to clip this because there's only one layer below it. We only have our chrominance data. So we'll just give our vibrance, and you can see what happens to our vibrance if we just ramp this all the way up. It's probably too much there. Turn off our luminance, you can see it better. Just our color data, you see that's quite vibrant there. You can bring it down if you wanted, but I think a little bit of a ramp up of vibrance and then a little bit of saturation as well. And I think that's looking good. Let's have a look here. That's looking good as well. So I think we can play a little bit with the colors. I think I'd like to accentuate this color a little bit more. So we can have a look at masks. So for masks, we deselect everything. I just want to play with the colors. So we just want to have the color selected. We do our chrominance, and now we do a select color range. Now you can just click on a color. So we want this kind of teal data. With this teal data there, and fuzziness is just how loose you want to be with that color selection. So colors that are kind of like this color. So if we go all the way up, it's going to just mask everything, but we just want to create a mask around about there. I would say looks good. If you click on OK, so now if we select an adjustment, it's going to create a mask of this color range. So if I go to my adjustments, my chrominance, go to adjustments, color balance. So if I just click on color balance now, it's created the color balance, but it's also applied a mask. So when I change the color balance, it's only going to change the color balance of everything that's masked out. So I can now move this a little bit more towards the cyan. If I go all the way over here, that's something a little bit crazy. But if I just apply and move the red, a little bit less red, move it towards teal, and a little bit less yellow, move it towards blue. And again, we can turn this layer on or off just to see what the adjustment is. It's subtle, but it's definitely moved it a bit more towards the blue, which is nice. So I think this is not too bad. I think I can bump the saturation just a little bit more. Can have a look at it with it's looking a little bit better. So I don't want this video to be too long. You can spend hours tinkering in Photoshop. I just wanted to give everybody a feel for how Photoshop, I think, has strengths in processing data, and I think its strength is if you have everything split out, you can adjust those layers independently. So you can play with adjustments on the color data, just on the color data. You can then play with contrast adjustments then on the luminance, and we haven't touched or affected our stars at all. We can just add those in. Completely overwhelmed everything. But if we just take a curves adjustment here for our stars, and we want to clip it because we just want to apply it to our stars, you can then adjust to taste how much influence the stars would have. So you can bring those stars right down if you want. The colors are all still there. All we're doing is reducing the brightness of our stars until they blend nicely with the rest of the data. So if you want the nebulosity to shine through a little more, you can bring that slider all the way down, in effect removing a lot of stars. They'll get screened out. If you want more stars in your image, go for it. You can make this a star-centric image, and everything else is background. But for this, I want the nebulosity to shine through a little bit, so I'm going to de-accentuate these stars just a little bit. I think maybe about there seems pretty good. And I would continue here. I think next thing, I'm not going to do in this video, but next thing I do here is I take some the luminosity data. Let's do it just to show you again. I turn off the stars because we only want the selection on the nebulosity. If I want to bump up the luminosity of just the teal area here, I can do a select color range. Just the fuzziness. Now, if I apply a curves adjustment on this data and go to curves, I can bump this up, and it's just changing the luminosity of the oxygen 3 only area until I'm happy with it. And you can turn that on or off. So that's before, after. So you can tinker away. It's non-destructive, and some adjustment that you'll make later, you'll need to come back and readjust something you've applied earlier. But you can do that again with Photoshop because it's all non-destructive. And I think, as I say, not to harp on too much about it, but I think when you have your data and you split it all out, combining it, and this is where the artsy bit comes from. And I think Photoshop is the best tool for for tinkering and playing like this. So I'm going to leave it at that. I hope the video wasn't too long. Hope you enjoyed it. Hope somebody out there learned something from this, and I hope at least you'll give it a try. This certainly is not the only way to do this. You can do all of this in PixInsight if you wanted. It takes a lot longer to do, and you have to go back. You have to completely undo what you've done in PixInsight, because it's destructive. When you change the image, that's it, and you can't apply another adjustment and then go back and readjust slightly what you've previously any previous adjustment. You have to go all the way back and reapply all the steps. So if we just turn the stars back on, I think I'll leave it at that.